Namaskar, I am Parth. In the previous video, I showed you the manual implementation of finding connected components. In the second part of 8 connected neighbors, there was a mistake. I asked viewers to find and comment the mistake. So in this video, I'll explain and rectify that mistake. We will also show how to create and display bounding boxes from the list of pixels which we have obtained. Okay, so let's start. I will use this Excel file which we have used previously. I recommend you to watch the previous two parts because I will not explain everything here. I will just rectify and show the mistake. Okay, most of you might have seen this template, but please watch the previous videos if you have not. Okay, I'll create a scenario here for you to understand the mistake, right? Suppose this is the case, labels are like this, and we are labeling from here, and this was the pixel. Suppose we came, so what we will do? First we will check this. It was 0, suppose it was not labeled, I mean. Okay, now we have to label this one. This is the only white pixel in the boundary or in the neighborhood. So okay, first we will check this v3, right? Okay, we will check this one, this value, that is this. It is not labeled, so it's okay. Now we will check this value, and yes, we will do same as it is. Okay, now we have stopped here, but see in this condition, first we checked v3. v3 is this one. This is v3, which is currently 0. Okay, so if v3 is not there, then we check v1. Okay, this is v1, which is right now 1. Okay, so we checked v1 and we gave the value of v1 to our current value. This is our current value which we given 1. Okay, but see this is 2, then they both are connected, so it's all a single component, like this much, this, and this. It's a single component. So after checking v1, we also need to check v2 and v4. We won't check v2, but we have to check v4, right? So there is only one statement to add, that is we will check v4 if v1 is present. Okay, I think I'll copy it from here. See, v1 is present, so I'll write here. Okay, now if v1 and v4 are same and v4 is also greater than 0, then change all v4s to v1, right? I think it's right. Let me just recheck it. See if they are different and v4 is available, right? Then what we will do, we will change all v4s to v1 or v1 to v4. Yes, it's right, v4 to v1, I guess. No, we'll do it reverse. We'll change all v1s to v4. We can do either way, it's not concern, right? Okay, it's fine. So that is the only change we are supposed to make. Okay, now we will end this if statement, and now we will check if it's done properly or not. Okay, so I will take the image of cameraman. Okay, I will binarize it. and we will find connected components. First we will use inbuilt command. Okay, now this was our command. Internal command is not coming. Yes, it is BW, COW and COMP. It is B and 8. Okay, let's check the answer. Okay, it says 27 objects. Okay, now we will use our function. See, it also says 27. Let me just show you pixels also. These are from inbuilt command, and we have n as okay B. 8, 8. I missed the 8 here. Okay, NCS, right? So see, your n is 27, so there are 27 components, right? Okay, I figured out why these are empty cells, because I have done a mistake here. It will be not values of, it will be simply v plus 1, because we have ordered all the labels by this for loop. Okay, so now we'll run it. Let's check. And yes, now we have all the values. Still we are missing one, because I think we have written v plus 1. It should be simply v. Okay, now it should be completely fine. Yes, and I can also show you like the difference between our pixels and inbuilt functions pixels. Okay, see, the biggest object I guess is 42939. Okay, what is our 42939? So yes, we are getting the exact same output. Now there is no mistake. The mistake is rectified. So if you have watched the previous video, then let me state the two mistakes. Here it was like values of v plus 1. There we changed labeled image equal to v, and the other mistake was these three lines need to be added. Like if we are checking this value, then we also need to check this value, because there can be a possibility like such case would happen in any image. Okay, so that's it for this connected component. Now what we will do, now I will show you how to create bounding boxes with this S. You have now number of pixels, so you might need to create bounding boxes, right, using these pixel values. Now see, it is easier in this case to build bounding boxes, but if it is only like one pixel object, then it is hard. So we will have like some threshold, like if there are more than some number of pixels, then we'll create our bounding boxes. Otherwise we won't create boxes, right? So I will do for the like maximum, I will find the object with maximum number of pixels and draw the bounding box over it. Okay, so let's do that. See, this is our S, right? So we'll run a for loop, and we will find the index of maximum sized pixel list. Okay, or we can also do it from here directly. I will name it temporary, right? And we'll store size is every rhyme, right? we'll append this every time. We will create a blank array here. This is not a good practice to create blank arrays. If you know the size, then every time you have to like create the array of specified size, like size is equal to zeros of n. Then it will take a less time, but currently I'm doing this way. It won't matter. See, it will show you error. The variable size is appear to change size on every loop. So it will reduce the speed, but it's okay for now. So I'll just run it and check what is the size, right? Okay, size is, and it's one. Okay, it's like first time it came here. Okay, okay, now we have sizes of all 27 values, and it is 42939. So that is the maximum. It is 25th. Okay, so maximum index, max index, I will name it, is equals to maximum of sizes, find sizes equal to maximum of size. There may be another way, but currently I don't know. So it is like we will find the value. Here it will come 42939, and then it will find the index of 42939. There should be a like something functionality in this function max to find the index, but right now we don't do that part. We are not optimizing code. I'm just showing you the manual implementation. It would take a whole session to show you how to optimize the code. Okay, so now we know. So now we'll extract that. Okay, so big component or max sized component is equals to s of max index. Okay, now let's just test like we have got our maximum component or not. Okay, so we have the pixels of maximum. Okay, that's it. So now what we'll do, we will find maximum I. Firstly, what is the problem? We have their one dimensional location. We need their two dimensional locations, right? So what we will do, first we will obtain values of that locations, right? Or there can be another way of doing this. Let me think. See, I found out the function. By using it, we can do this. See, we will find row column equal to function indices to subscript. We will have to provide the size and we have to provide the indices, right? So let's test it. We will write inside. Okay, so size we know is 256 cross 256, and I think we might have it inside here. Let me just run again. So do we have sizes? Okay, we don't have sizes, but we may have. Okay, yes, we have s. So we'll just save s. Now we will have s. It is 258 cross 258. I'm sorry, it is the padded size. Okay, we don't need padded size, so we will find size once again, right? We will find it here. You can do it anywhere, just I'm doing it here. We'll find size of lim. It's okay. Let me run again. So now we have SCS 256 cross 256. Okay, so what we will write is rows, comma, columns is equals to ind2 sub, I guess. Yes, we have to provide size s and indices we have in this variable maximum component or maximum sized component. Okay, so now let's test this. Do we have rows and columns? Yes, we have rows and columns as well. Okay, so we will find minimum row, minimum column, maximum row and maximum column, and there we have our bounding box, right? So let's do it. Suppose we are having like let me show you. Suppose the minimum and maximum values we get would be like this. One is here. We have to not just find minimum and maximum row, right? We have to find four rows. This is first, second, third and fourth. Then we have to decide that this is the minimum row and this is the maximum row, right? We have to align it. So let's just first find minimum maximum values, then we will see what else is required, right? Okay, okay. One more thing we have to find, I guess, the associated column. Like the minimum row is first row, then we also have to find its associated column, right? So it can be like at multiple locations, so we have to think here, but let us just find out what are these values first. Okay, what is the mistake? Columns, I think I have done it right. Where is the error? Line 68. Oh, I done a capital C. It's okay. Now let's see. Okay, maximum column is 256 and minimum column is 1. Okay, and it is also 1 and 256, but we have to find its corresponding values, like I said, right? Okay, let's find the associated values. Like this is the row mean, then column underscore row mean. I'm just naming it so that everyone can understand what it is. And this will be column underscore row max. So okay, now how to find it? So it will be columns of which, then find rows equal to row mean, right? So suppose we also have to do something else, but I will show you when the error comes. Okay, it will be same. Just we'll do row max here. Okay, let me just run and show you so I can state the mistake, right? Okay, what are the, see, there are 143 values here and 256 values here, right? So what we will do here, we have to again find minimum and maximum values both. So that's the complex part, I guess. First of all, let me think if there is any easy thing, then we will dive into this. Okay, these are the minimum values. and these are associated columns with the maximum row values, and maximum row is 256. So like in the last row, these are the columns where we are having the pixels of our connected component. So what we need is minimum row minimum column, maximum row maximum column, that both points we need, and still we need two more points, right? Okay, so I think I got the point what we need to do. We won't need these columns. Okay, right. Now we will need now just two values here, uh, minimum row and minimum column, minimum row and maximum column, right? And maximum row minimum column, maximum row maximum column. So we'll do one more thing. Let me just separate these all lines so it may be easy to understand. See, this is a little bit complex thing, but I'm sure if you will give attention properly, then it is easy to understand. Okay. So here we find all the associated columns with minimum row. Now still we need two columns, one maximum of it and one minimum of it. Okay. So I will name C1. C1 will be minimum of this one associated with minimum row, and C2 will be maximum of associated with minimum row. Okay, same thing we will do here, which will be our C3 and C4, and here it will be like maximum C4 maximum and C3. Okay, now we have it, right? Now we will show the rectangle. The command is for the command is directly rectangle. Okay, for that purpose the command is rectangle. We will see the syntax of that command and we will write our code accordingly. It is always better to use Matlab documentations. Okay, what are the options we have? Here I know it requires XY positions and not our rows and columns, right? It needs XY positions. We have to look that twice. Okay, let's just try our best shot, right? Let's see an example. X1 y1 x2 y2. So no, it is like yes, x1 y1 width and height. Okay, I got the point. Okay, let's try. Okay, so what we will do, I am show. It will be the input image, I guess. So we are deleting input image, but we have to store. Okay, I am sure. Then hold on. Then we'll do rectangle position. Then we have to give here x and y. So what will be our x? X will be the origin point. Okay, so it will be our minimum column, I guess. Yes, it will be minimum column, so it will be C1. C1 is our x. And then we have to give y1. Y1 is our minimum row. Okay, now what is width? Width is C2 minus C1. Yes. And what is height? Height is I think rho maximum minus rho minimum is height, right? Now let's test this. I don't know it would work or not, but I guess it should work. Okay, I think we are getting the result. I'm not sure. I have not specified any color, so yes, yes, the box came. This is the way of creating bounding boxes. Okay, yeah, so we'll end the video here. It was a lengthy video, and I might have made mistakes today because I'm creating video after a long time today. So thank you for watching the video. Please like, share, and subscribe the channel. And if you have any queries regarding this video, this mess I have created in the last part, please ask out in the comment section. We will reply within very short time. Most of you might know, many of you are contacting us for various queries, and we have responded. Thank you.